Good evening, sir. Good evening, sir.
Good evening, madam.
Yes, sir. Shall we start the program, sir?
Yes.
Yes, sir. Good evening to everyone. We are assembled here for the online international workshop on Jamovi made simple, organized by Akman Foundation and Seva Academy. Today we have our resource person, Dr. Chaudhary, sir. Sir, as yesterday introduced yesterday, sir is working as Associate Professor of Statistics in MG Science Institute, Ahmedabad, Gujarat. Welcome you, sir, to the session.
Thank you,
Welcome you.
madam.
Sir. The session is yours, sir. Please.
Thank you.
Thank you. Sir.
Okay, good evening, all. Uh, Hope you practice yesterday's topic, that is about the understanding Jamovi. Uh, because before we start statistical analysis, or before we start using the higher statistical analysis in Jamovi, first we need to understand how to enter the data, how to manipulate the data, how to transform the data, and how to manage the data, right? Which includes the data types. Then we have the variable type of data which we are using, right? So the next part is about the data exploration. Actually, it is also known as exploratory data analysis, right? The another word for this is exploratory data analysis. So basically, in exploratory data analysis, there are two topics. It is classified into two categories. One is the visualization of data, and another is the summarization of data. So, whatever the data we collect through questionnaire or through survey, so first we enter the data in appropriate format that is suitable for the software. If you are using SPSS or if you are using Jamovi or any other software, Minitab is there, right? So depending upon the software, first we have to code the data. So in Jamovi also it is the same thing. So according to me, it is good practice to prepare the entire data in Excel, because Excel is easy to handle and everyone is familiar with Excel. So we can easily enter the data, and the concept is whenever we prepare a data file, always we have columns are the variables, whatever the number of variables we have. So columns are the variables and rows are the responses or the information given by the respondent. So that is the general concept. In almost every statistical software, we need this type of structure. So columns are the variable, rows are the cases, or what we call it as the responses, right? So once you prepare the data, either in Excel format or in CSV format, or it may be in the text format, then we import that data into the software, say SPSS or Jamovi. We are discussing Jamovi. So yesterday we have seen how to import the data, right? Just you can open and you can select the appropriate file type and you can import the data. Once the data is imported, so it is not suitable for the statistical analysis. So once the data is imported, the next step is the coding part, right? So in the coding part, we have to specify the type, data type, that is nominal or ordinal or scale type data, that is continuous in case of Jamovi. In case of SPSS, we call it as a scale data, right? And then in case of the nominal and ordinal data, we have to label, we have to give the labels. Say in case of gender, we have to assign the label, one for 0 for male, one for female, and so on, right? For nominal as well as for ordinal, right? So once the coding part is over, now our data is ready for the analysis purpose. So the next step is, before applying any higher statistical techniques or higher statistical methods, the first step is always data exploration. So what is a data exploration, right? So data exploration is nothing but getting insight about the data. We try to understand the data, what data says, what particular variable, one variable or two variable, or relationship between one or two variables. So that we need to understand, right? And that can be understood by using a visualization technique or by using a summarization technique. So that is why exploratory data analysis, it is also known as EDA, right? So exploratory data analysis consists of two parts, right? So that is uh, data visualization, then data summarization. So in each and every research project, right? So this step is necessary. It is a crucial part of every research project, right? That is exploratory data analysis, right? Before fitting any model or before applying any model, before applying any hypothesis testing technique. So first step is always examine the data with the help of different visualization tools and then different summarization tool, right? Again, as you know, there is a popular saying in terms of the computer that garbage in, garbage out, right? So you can give anything as a data and it gives you the output. But whether that output is suitable or not, it depends on the type of data, right? Even in data visualization technique, it depends on the type of data, whether to use histogram, whether to use bar chart, or when to use box and whisker plot, right? So that everything depends on the type of data and the nature of the data, right? So that is why exploratory data analysis is very, very important technique or tool to understand the data, right? So, like in, say, for example, if you want to apply the regression, right? So before applying regression, we should understand that regression technique is applicable. Linear regression technique is applicable only when we have the dependent variable is continuous and it follows a normal distribution. So there are certain assumptions, right? So we need to understand. Say, for example, t-test. So before applying t-test, we have to verify whether the data is normally distributed. If the data is not normal, then we have the alternative statistical method for hypothesis testing. Okay, so in EDA, so what actually this exploratory data analysis gives you? This exploratory data analysis gives us idea about the unusual or the typical values in the data, right? Suppose I have the data about, say, for example, age, right? And in almost 90%, 95% of the cases, my data is within a specific, my age group is within a specific limit, right? And one or few observations are beyond that limit, right? So that is unusual observation, or that is known as a typical value. Okay, so EDA gives us idea about the unusual or the typical value. At the same time, if you are if we are talking about the uh, numerical data, the center of the data is important, right? Center of the data. That means what is the average? Usually, we know that whenever we talk about average, so always we think about the X bar, that is sample mean or mean simply. Okay, but that is not the case. So there are three different types of averages, that is mean, median, and mode. And depending upon the type of data, we have to use appropriate average, right? So for a symmetric data or for a normally distributed data, mean is a suitable measure, right? But when we have asymmetric data, like skewed data, we will discuss about that in today's session. We can use median, right? Similarly, mode. So in case of the nominal and ordinal type data, mean and median are not suitable, so we go for mode. Similarly, this exploratory data analysis, it gives you idea about the spread of the data. That means how much is the variation in the data. So commonly used are the variance and standard deviation. One more formula is there, that is range. Another is there, interquartile range or mean deviation, right? So, but these are the commonly used technique. So, in general, EDA gives you idea about the unusual values. It gives you idea about the center of the data, about the spread of the data, how much is the variation in the data. Say, for example, if you collect the data about height, so how much is the variation in the data of 100 individuals, height of 100 individuals. So, how much is the variation? Right? So that can be measured. And what are the extreme values? Again, this extreme values gives you idea about the spread of the data, range of the data. What is the minimum age? What is the maximum age? Or what is the minimum height? What is maximum height? So it gives you idea about the range of the data. So that is why it is necessary. So when we use exploratory data analysis tool, it gives you idea about these points, right? Then the next part is how to explore graphically. So you know that there are different type of charts, and as I told you in softwares, when you the as I told you that garbage in, garbage out, right? So you cannot apply any technique to any chart to any type of data. So there are specific rules for each type of chart, right? So what are the different type of charts and graphs, right? Many of you are familiar with all or some, right? So we will discuss in detail. So pie chart is there, simple bar chart, multiple, which is also known as a cluster bar chart, or it may be a stacked bar chart, histogram, simple box and whisker plot. Then we have a cluster box and whisker plot, and we have a scatter plot. So these are the most commonly used charts or graphs. Apart from these, there are some advanced or additional plots also, right? So like violin chart is there, right? Now the question is when to use which chart. So as I told you, the type of chart depends upon the type of data, what type of data you are using. So it depends on that. Say, for example, just think about this table. So we have the first variable, one variable, which is categorical, right? So for categorical variable, Categorical means either it is nominal or ordinal. So always we use a bar chart, always, or we can use a pie chart. There is a very thin line between the bar chart and pie chart. So pie chart and pie chart, bar chart, they are used for nominal as well as for the ordinal type data. But when we have the number of labels are large, say for example, in case of gender, we have only two labels, male and female, right? So either you can use pie or bar. But suppose we have more than six labels of certain variables. Okay. In that case, the pie chart is very uh, clustered, right? That means number of slices are there and it is very difficult to understand that. So basically when the number of labels of a variable, categorical variable, are less than or equal to 6. This is not a hard and fast rule, but the rule of thumb is if it is less or equal to 6 or 7, up to that it is okay. But for more than that, always we prefer a bar chart. Okay. Another is if we have a scale type data, one variable which is a scale type variable. Scale means continuous variable like height, weight, profit, right? Blood pressure. So in case of the scale variable, always we use either a histogram or box plot, which is also known as a box and whisker plot, right? Histogram or box plot. Now again, in the bar chart or bar plot, we have the bars. In histogram also we have the bars, but there is a difference. The difference is in bar chart, the gap, there is a gap between the labels. But in histogram, there is no gap because your variable is a continuous variable. So all the or the bars are adjacent to each other, right? Another thing, when we have now, suppose I have more than one variable. So one variable is categorical, another second variable is also categorical. Then we can represent it with the help of either multiple bar chart or stack bar chart. So multiple and stack we can use alternatively. So multiple means side by side and stack means one over the other, right? So for two categorical variable, we can use the multiple or stack bar chart. Suppose we have one variable is categorical and another variable is scale, right? So scale variable and categorical. So look at this graph that is known as a sorry, that is known as a box and whisker plot, but it is not a single, it is a multiple box and whisker plot. So if you look at x-axis, so we have a categorical variable, gender. If you look at y-axis, we have the numerical variable, that is continuous variable, weight. Okay, so for the comparative study, this multiple box and whisker plot is very, very useful. So when we have one scale and another categorical, we can use box and whisker plot. Same situation arises in this case. Here also, the first variable, one variable is categorical, another variable is scale. So again, we can use a box and whisker plot, that is multiple box and whisker plot. And if both the variable are scale or continuous, we can always use a scatter plot, right? So along x-axis, we have one continuous, along y-axis, we have another continuous variable, and we have a scatter plot. Every pair of point is plotted as a point, and we have a scatter plot, right? So this is how we can choose appropriate chart depending upon the type of data, right? So whether it is a categorical, nominal or ordinal, or whether it is scale or continuous. So depending upon that, we can use appropriate chart. So this is all about the selection of appropriate chart, right? And now the bar chart or pie chart, the definitions and everything that you know very well, and you can find it in many books, right? But specifically, it is used for the categorical data. Either it is a nominal or ordinal, right? And it consists of the group of equidistant rectangles, one for each group or category, right? and height of the rectangle represent the count in each category. Say for example, if you look at this graph, this bar plot, right? So here we have the adjacent, we have the uh, two bars, right? One for female, another for male, and the height of the rectangle is important here. The width of the rectangle, we have similar width of the rectangle, right? But it doesn't matter whether you prepare a smaller width or larger width, but height is important, and that gives you the count, that is number of female candidates, number of male candidates, right? So this is how we can create a box and whisker plot, right? Now, the bar plot. Okay. Now, how to do this in Jamovi? As I told you, as compared to SPSS, Jamovi is very interactive and dynamic in output. Okay. So we will see how it is different from SPSS. In SPSS, once you create any chart, once you have used that technique, graphical technique, right? And once the chart is prepared, and if there are some mistakes, you have to remove that output and you have to rerun the analysis through SPSS. But in Jamovi, that is not the case. Once you create the graph, and suppose you want to change something, so you can change. You want to change the variable, or you want to change the categorical variable or continuous variable, that we can do, right? And different options are available, right? Now let us see how this can be done in Jamovi. So let me open this file, that is hard study, right? The same file which we have used yesterday for the coding purpose, right? So this is my data file. And as you know that there are some number of variables, right? Starting from gender, first one is always ID, and it is good practice to keep the first variable as first column as ID, so that we can recall, or you can rearrange the data according to the initial stage, right? So then we have gender, socioeconomical status, then education, weight, height, age, smoking status, physical activity, blood glucose, serum cholesterol, systolic blood pressure, right? So these are the original data, right? Actual data, and then this BMI and the next BMI category, right? So this is the BMI category. If you click on this, it gives you the BMI category. If you click on this, it gives you BMI, right? Body mass index. Here it gives you the BMI Z score, right? So remember, whatever the variables you have computed or you have transformed, so always it shows here these three numbers, three dots, right? So look at this. For the BMI, it shows a black dot. For BMI category, it is coded from the numeric to categorical. So it shows the red dot. And this is the transformation technique, that is BMI Z score, it shows the blue dot, right? That means these three variables are not original variables. They are computed or transformed from the existing variable. Okay. So this is the structure of my data file, and we have 100 respondents data, right? Now how to open that, you know very well. So just go to this menu, then open and select the appropriate folder and select your file. If you have Excel file, so open the Excel file and change the data types and all these things, so that the data file becomes suitable for the analysis, right? Like this measure type and data type. So that you have to change, and you have to add the labels as per the as per your variable, right? So once the data is ready, now the next part is, as I told you, the most important part, that is the exploratory data analysis, right? Say for example, exploring the categorical variable, right? So if you go to this option, first go to the analysis tab, right? On the analysis tab, on the ribbon, we have this exploration. In the exploration, the first part, that is the descriptive, right? So once you click on the descriptive, it gives you this is the selection for the descriptive tool. Okay. You can see here the list of variables. All the variables are there. Okay. And to the right of that, we have the variable selection. So you can select the variable, right? Here you can select the variable, and extremely right, we have the output window. So this is the output window where your output, whatever the tools and techniques you are using, so the corresponding output will appear in this section, right? And just below to the descriptive section, we have some two options available, right? So look at this statistics, right? So if you click on that, it will expand that particular region, right? And the various options are available, right? So these are the options which we can select, right? So check boxes are there, so we can use the check boxes. Similarly, in the plot section, we have different options are available, right? Now there are two ways to do this selection. Say for example, if I am selecting the gender here, right? So there are two ways to select. Either click on the gender and click on this arrow, okay? And again, if you want to remove that, so click inside that box and then click the reverse arrow. The automatically the arrow side will be changed, okay? Another way is you just drag and drop. Okay, using mouse, you can just drag and drop, right? Now see, actually gender is a categorical variable, and you can see here before that gender variable name, we can see the icon, right? So it shows that it is a nominal variable, and for the nominal variable, mean, median, mode, standard deviation, they are of no use, right? Because for the categorical variable, okay, for the categorical variable, mean, median, they are of no use, right? So how to overcome this? So see, by default, in the descriptive summary, always we have these are the options. Okay. That is what is the number of observations, how many missing values are there, mean, median, standard deviation, minimum, maximum. Right? If you want to change, you can change from the statistics section, right? But since my variable gender is a categorical variable, I am not interested in the this type of summary. I want a frequency table. So you can click on this. Just below this split by, we have a frequency table, right? So we get a frequency table, right? So this is the frequency table which is of interest for us, right? So just select the frequency table, and then from the statistics section, we are not interested in mean, median, or minimum, maximum, and standard deviation, right? Because that is not suitable for the categorical variable. Okay, so this is how. Now, what actually it gives you? If you look at the frequency of gender, right? So we have female, male, how many actual counts are there in each category, right? So 48 female, 52 male, and the total data is 100%, 100 individuals, and it gives you the percentage of total. Similarly, percentage of the cumulative percentage. It is exactly same to that of the SPSS, right? But the problem is, suppose here I want this summary. So again, look at this. This is not possible in SPSS. When you click on the output table, automatically the same option will appear, right? Once you click on that, automatically the same option will appear. Suppose I want this table as a descriptive table as a row wise. So you can see here, this is row wise, right? So that is for the numerical data. Okay, that is for the numerical data. Okay, but suppose I want to add, I want to study this gender and along with the smoking status, right? Or say, for example, socioeconomical status, right? And you can do this, say for example, gender, you can take in the split by option, and socio-economical status in the variable. So again, socio-economical status is a categorical variable, ordinal type data, right? Here it shows the number of observations, right, in each category, and missing values, right? Now, if you look at the table, so see, low economical status, female and male, how many? Medium economical status, female and male, right? And high economical status, female and male. That means the table, whatever the table output you get in Jamovi, that is dynamic, right? So you can change that. Okay, you can change that anytime, right? Say for example, I am removing this, so it gives me only about the frequency of socio-economical status, right? So this is how it is very, very different from SPSS, right? So this is the same thing when we are studying the categorical variable. So mean, median, standard deviation, so these uh, measures are not useful for the categorical, so we need to remove them, right? So and we get this type of data output. Okay, another important thing is, since my data is categorical, I need to plot the graph also. So actually here it shows both histogram, box plot, bar plot, right? But you have to remember that since my data is categorical, I have to select a bar plot. Okay. And once you check that bar plot, you can see the bar plot for that socio-economical status, right? So that is simply a bar plot. Okay. Again, if you click on that, and suppose I want the bar plot, right, for a different variable. So just remove that and add gender. So you will get the bar plot and everything, right? Similarly, suppose now this is final, and suppose I want to add another output, right? I want to add another output, right? So remember one thing, when you click on the existing output, it will always open the options, analysis options, right? If you want a new output, new chart for a different variable, say for example, this we have prepared for gender, right? And suppose I want another, so again go to exploration, descriptive, and then say for example, select SES and select gender, right? And click on the frequency table, click on the statistics option, remove this because that is not required. Okay, and then just minimize the statistics and select a bar plot. Okay, select a bar plot. Now see, uh, you get all the output. Look at this according to gender wise and educational status, right? Sorry, what we have selected? Okay, we have selected both. Okay, so let's remove this. Okay. Okay, so according to gender and economical status, we have the frequency and the cumulative frequency, and accordingly we have a multiple bar chart. Okay, we have a multiple bar chart, right? So it is very easy to use all these tools comparative to SPSS, right? So again, anytime if you want to change, you can click on that and you can see this, right? At the same time, Uh, okay, so let us move to the next part, right? So this is about the bar chart, simple bar chart. This is about the multiple bar chart, right? So we can have a multiple bar chart also, right? And you can add, not necessary. Suppose I am adding educational level here, right? So it gives me different output, right? So look at this. We have different groups, right? And here we have what we call it as the legends. Okay, 1 minute. See, we have the legends also, and we have the categories also, right? So this is very easy to manipulate or to apply the commands in Jamovi. Okay. Now the next part is the descriptive summary. The remaining part we will discuss one by one, right? Now the descriptive summary, descriptive statistics for a numerical data. So when we have to study the numerical data like height, weight, blood pressure, serum cholesterol, or profit of a company, right? Marks obtained by the student, scores, right? And all these things, right? So we need to understand these things, right? So center of the data, that is again important. So mean, median, mode, then spread out. How much is the spread out in the data? So for that we can use range, interquartile range, variance, standard deviation, then extreme values, minimum, maximum, and what is the shape of the data distribution, right? Shape of the data distribution means what is the shape of the variable. Say for example, if you have the data about height, so what is the shape, whether it is symmetric or asymmetric, right? So for that we need to understand the skewness and kurtosis, right? So, and you all are familiar with this. So measures of central tendency, that is mean, it is the average sum of observations divided by the total number of observations. Median, it is a middle value after arranging the whole data into ascending or descending order, the middle value of the data, or the value which divide the whole data into two equal parts. So that value is known as a median. And mode is the most frequent or ideal value of the data, right? The value which occurs maximum number of times, that is the mode, right? Then we have the measures of dispersion, right? So what are the measures of dispersion? It is used to study the variation in the data, scatteredness in the data. Okay. So range, that is maximum value minus minimum value. Interquartile range, so we have the difference between the third quartile and first quartile. What are the quartiles? So just like median divide the data into two equal parts, quartiles divide the entire data into four equal parts. Okay, so when we have two equal parts, we have one number. For four equal parts, we have three numbers, Q1, Q2, and Q3. So they are known as a quartiles, right? So interquartile range is Q3 minus Q1. This is the formula for variance, which is popular. How the observations excise are deviating from the center. How the observations are deviated from the center. So that gives you the spread of the data. If all the observations are same, then the variance is zero. Because if someone scores 60 marks in all five subjects, right? So what we have 60, 60, 60, 60, all five subjects, right? So there is no variation when you plot that data, five data point, so it appears at the same position. But suppose someone score 40, 50, 60, 70, 75, and when we plot them, right? So they appear at a different location. So that gives you the spread of the data, right? So that is why variance is very useful. And when we take under root of the variance, square root of the variance, it gives you the standard deviation. So again, that is very, very important. Okay, so center of the data, because while applying statistical analysis, the important thing, four important things are there. One is the center of the data. Second is spread of the data. Third is skewness, that means symmetry of the data. And third is kurtosis, that is peakness or flatness of the data, right? And depending upon the values of these measures, we can choose a different statistical you can use different statistical methods, right? So skewness means what? It is a measure of symmetry, right? The meaning of skewness is a lack of symmetry, right? So that means whether there is a lack of symmetry or not, right? So what it gives you? It gives you idea about the concentration of the higher values or lower data point, higher or lower data point around the central value. If some of the in some of the variable, if we have the concentration of higher data points is more, right? then we have a different type of chart, right? So that is why the skewness is important. So when we have a bell-shaped structure, exactly bell-shaped structure, it means that the data is symmetric. There is no skewness. But if we have one side more elongated than the other side, then we have skewness, right? Either positive skewed or negatively skewed, right? So what are the measures? So we have Bowley's measure of skewness. It is based on the quartiles. I will show you how it works. Then we have Carl Pearson measure of skewness, right? It is based on mean, median, mode, and standard deviation. And the last one, that is moment measure of skewness, right? So look at this. If you look at this box and whisker plot, the name box and whisker. So this is the box, right? And at both ends, there are whiskers. So that is why it is known as a box and whisker plot. Okay. So if your data is symmetric, right? So Q2 is the center of the data, that is median. So Q2 is this Q2 is equidistance from Q3 and Q1. So this distance are equal, then we have a symmetric data, right? This is another. So Q2 and Q3. So that distance, that particular distance is more as compared to Q2 minus Q1. So this is a positively skewed. The in this case, the rectangle, second half of the rectangle is wider and the whisker is longer, right? Exactly same way we have opposite of that, right? So this is about the negatively skewed data, right? The same thing. Now, what is a box and whisker plot actually? So box and whisker plot is based upon the 5-number summary, right? For any numerical data, we have a 5-number summary, which is also known as a Tucky's 5-number summary. Tucky is the name of the scientist who gave this measures, right? So that is minimum, first quartile Q1, median or Q2, third quartile Q3, and maximum. And we have the interquartile range, that is Q3 minus Q1, right? If you look at the graph, so this box and whisker plot is very, very useful plot, right? So look at this. The first vertical line, this first vertical line, so that is either minimum or I will show you that, right? So this is the minimum value. The last one is the maximum value, right? And this rectangle. So the first edge of the rectangle is Q1, the last edge is Q3, and the middle of the rectangle is median. So we have minimum, Q1, median, Q3, and maximum. So that is a 5-number summary, right? But as I told you, many times we have some unusual or typical values in the data, right? Now, how to handle that, or how to identify that unusual or typical values are also known as outlier, and there is a separate technique to handle outlier. That technique is known as imputation, right? If your data contains outlier, right, and if you remove the outlier, it can be considered as a loss of information. So instead of removing the outlier, we can use imputation to replace the outlier values with the pattern of the data. So that is known as the imputation technique. Okay, so look at this. These 2 points are outlier to the extreme left, and these 2 points are outlier to the right, right? So under that situation, these vertical lines, end of the whiskers, they are not the minimum and maximum, right? So when we have this type of data, so actually what we can do, we can calculate the quartiles, we can calculate interquartile range. So Q1 minus 1.5 into interquartile range, right? Find out this value. If any value of the data is below that, then it is outlier. Otherwise, if nothing is below Q1 minus 1.5 IQR, in that case, your minimum and this, they are identical. So last boundary is the minimum. Same is to the extreme right, right? So if find out Q3 plus 1.5 IQR. If any value is above that, it can be considered as an outlier, right? So this is how we can use the box and whisker plot to trace out outliers. And if there are outliers and still you apply different statistical method, it will affect your interpretation, right? So that is why we have to treat the outliers, right? So this is about the outliers, right? Now, what is the Pearson measure of skewness? So we have mean, median, mode. If they are identical, we have exactly a bell-shaped structure that is known as a symmetric, right? If mean is larger than median is larger than mode, then we have this type of structure. It has a longer tail toward the right hand side. Such a data is known as positively skewed, which is not symmetric. And the third one, if it has a longer tail toward the left hand side, then it is a negatively skewed, right? Why I am discussing this? Because depending if your data is symmetric, then only we can apply certain statistical test. If it is not symmetric, we have to apply different statistical test, right? That is why this is very, very important, right? And the moment coefficient of skewness. So this is the formula for beta 1 and gamma 1. It is based on the moments, and depending upon the value of gamma, we can have positive, negative, or symmetric, right? So I'm not going into the detail. This is just for your information, right? Now, in case of the kurtosis, it may be so see all the three charts, all the three graphs are exactly symmetric. If you fold from the middle, they are identical, right? But still, if you find out the average, so for all the three, average is same, center, right? Mode is same, median is same, but still their patterns are different, right? So this one is a leptokurtic. It has a peakness in the data, right? So majority of the data points are in this portion, right? If you look at the platykurtic, the spread of the data is wider as compared to leptokurtic, and it has plate like flat data, right? Flatness. And this is mesokurtic, that is a bell shape, right? So depending upon the value of beta, we can find out whether it is leptokurtic, mesokurtic, or platykurtic, right? So this is all about the different types. Center of the data. So we have discussed center of the data, spread of the data, skewness, and kurtosis. Remember, these 4 points, these 4 topics are very, very important for the statistical analysis, any kind of statistical analysis. Okay. Now, the next is how to explore the data, numerical data, right? So let us see, suppose I want to explore, the data which is different. Say, for example, let us say, again, go to exploration, right? Go to descriptive. Now, I am interested in, say, for example, weight and height. Let us take one only, weight, right? So as soon as you select weight variable, you can see the descriptive. Now, in this case, since my data is scale type data, continuous, frequency table is not suitable. If you apply frequency table, right? So it is not suitable for this type of data. Okay. So because see, when I select frequency, right, it is not uh, we are not getting any output. The reason is frequency table. So look at this. In front of the frequency table, it is mentioned that for it is applicable only for the nominal and ordinal type data. Okay. So this is the summary, right? So this is a summary for the first variable, say weight, right? If I want another variable, I can add height. So we have separate column, summary column for weight, height. You can add as many as you want, right? So look at this. We have the third column, serum cholesterol, fourth column, right? And suppose you want this in a different format across rows, so we can have the output like this also, right? Sorry. 1 minute. We can have the output like this also. So look at this, right? So the columns are the different measures, right? Columns are the different measures and rows are the variables, right? So rows are the variables, right? So this is how we can use. Okay, 1 minute. Mm, sorry. Okay, so this is how we get the output, right? And again, as you know, as I explained you, so you can change the statistics. Suppose mean, median. Suppose I want I don't want this median, but I want the quartiles, right? So look at this: 25th percentile, 50th percentile, 75th percentile. That is Q1, Q2, Q3 for each variable it gives you, right? Suppose if you want not four, but if you want, say, for example, 10 equal groups, right? So you can just change to 10 equal groups and you get 10 percentile, right? That is the 10th percentile. This is P10, P20, and so on, right? So depending upon the selection, you get the output, right? Instead of a cut point, if you specifically want 25th, 50th, 17th, you get that. If you want sum of the weights for each, right? So look at this. We have the sum of the sum of weight, sum of height, right? Sum of the glucose, and so on, right? So as per your selection, you get the output, right? So for simplicity, let us remove this one variable. Okay. Now, suppose I want skewness, so the skewness will be added. I want kurtosis will be added. Now, this is not possible in SPSS. In SPSS, once you have selected the process, once you have created the descriptive summary, that output becomes static, right? Here, the output is dynamic, right? At the same time, if you want to check the normality of the data, that means whether your data is normal or not, right? We can use the Shapiro-Wilk test. So it gives you the Shapiro-Wilk test output. So this is the test statistics, right? And W is the test statistics, right? And we have this Shapiro-Wilk P is a P value, right? So that is a P value. And based upon the P value, we can decide whether the data is normally distributed or whether data is not normally distributed, right? So that means from here, everything. So say, for example, if you want IQR, right? Instead of minimum, if you want IQR, so you get interquartile range. If you want range, you get the minimum value and maximum value and the difference between them, right? So this is how we can find out the summary statistics, right? So this is the summary statistics, and accordingly you can interpret as per your results, right? You can use the interpretation, right? So this is about the summary, right? Now for the same selection, right? See, in SPSS, for descriptive, we have a separate tool. For data visualization, we have separate set of commands, sequence of commands, right? Here, whatever the descriptive analysis I have obtained, right? So that is through the statistics section. And suppose I want the plot. Now, obviously, all my variables are numeric, okay? Weight, height, and so on. So I can choose histogram. So you can see different histograms are there, right? So this is a histogram for weight. This is a histogram for height. This is the histogram for blood glucose, right? So you will get different histogram for the selected variable. Suppose if you remove one of the variable, so automatically the output will be updated. Okay, only two histogram. Okay, at the same time, instead of only histogram, suppose I want density plot also, right? Density plot is on the histogram, we can superimpose a curve, kernel density, right? So this is a density plot. So it gives you idea about whether the data is symmetric or not, roughly, approximately symmetric or not, right? So that can be obtained using this, right? So we have histogram, we have density plot, right? Obviously, bar plot is not applicable for this type of data. Okay, so this is about the histogram and density plot, right? So you have a separate, depending upon your selection, you will get a density plot, right? Histogram with density plot, right? Now, suppose I select a box plot also, right? Now, look at this. What I am getting? I am getting a box plot for each variable in my selection. See, in my selection, I have selected height and weight, right? So I'm getting the box plot for height, weight, and box plot for height. Okay, so this is what we are getting here, right? At the same time, look at this. In case of the weight data, we have one of the point that is outlier, right? And this gives you the number 16th point, right? The 16th number respondent's weight is beyond the range of the actual weight, right? So let us see in case of the 16th, right? So this is my 16th column, right? And weight. So look at this. The weight of this 16th respondent is 91, which is beyond the range of the actual weight. Okay, so this is how it is very useful. Okay, so we can have a box plot. Okay, at the same time, suppose in my selection, see, I have selected only variables, but suppose I want to study weight of male and female. I want to study height of male and female, that means gender wise. So I can select gender and drop in the split by option, right? Drop in the split by option. Now see, starting from the summary, right? Starting from the summary, descriptive summary. Now it gives you the splitted summary, right? Say for example, mean for female weight, mean average weight for female candidate, average weight for male, right? Similarly, everything, skewness for female, male, that means the data is splitted according to gender. So for female respondents only, what are the summary measures? For male respondent, what are the summary measures about the weight? At the same time, in the comparative histogram with density plot, right? This is very interesting and important, right? Because we have selected histogram, look at this, we have selected histogram and density, so it gives me, because, and another thing, I have splitted the data. Okay, so weight is along x-axis, along y-axis we have male, a separate histogram and density, and for female a separate histogram. So you can compare, right? You can compare the distribution. Same way in a box and whisker plot. See, female and male. So that outlier is for male, but for female, there is no outlier in the weight variable. Same situation for the height variable, same box and whisker plot for the height variable. So comparative study is possible very easily and quickly using this particular uh, Jamovi. Okay, so using Jamovi, we can study that. Okay, so this is very simple tools to study the data, right? Another important option in this case is you can select the violin plot. Okay, so this is again a very beautiful and very interactive plot. What is actually violin plot? Look at this violin plot, right? So if you uh, rotate this 45 degree, right? Sorry, 90 degree. If you rotate the graph 90 degree, right, you can see the density plot, right? It is a density plot, right? Either this way or that way, but it gives you the idea about the density plot, right? So this is a violin plot, right? At the same time, we can add data. So see, when I selected the data, it gives me the actual data point what is the concentration of the data points, right? So these beautiful graphs are very useful in research paper, research publication for the comparative study. Okay, so these are the actual data points. Okay, these are the actual data points, right? And it appears in box and whisker with a violin plot. Okay, so if you remove violin plot, it shows only the box and whisker and data, right? It shows box and whisker and data, right? So that is known as a jitter. So actual data point, right? When I select stacked, right? When I select stack, it gives me the stack of the data. Say for example, so these many dots are there. So say for example, just take the last one, 1, 2, 3, 4. So these four female respondents are having the height near about say 151 or 152. So four. Now when I remove that stack and jitter, right? So what it gives you? See, these are the four data points. They are very closer to each other, right? So this is how we can use this. Okay. So this is one option, that is box and whisker plot, histogram, violin plot. Okay. So these are the actual data points, right? These circles are the actual data points. Okay. So now the another important chart, which is very, very useful. As I told you, before applying any statistical hypothesis testing procedure, we need to check the normality of the data. If your data is normally distributed, then only we can apply t-test, one sample t-test, two sample dependent or independent sample t-test, even regression analysis, even analysis of variance technique. These are the statistical techniques. So they are applicable when we have data is normally distributed, right? And to check normality, we have a Shapiro-Wilk test. Look at this. In the statistics section, we have a Shapiro-Wilk test. And in the output, we can see the Shapiro-Wilk test output, right? We have a Shapiro-Wilk test output. So these are the p-values, and based on the p-values, we have to decide whether the data is approximately normal or not. So this is using the Shapiro-Wilk test, right? But there is one more technique to check the normality, that is a graphical technique, and that is a QQ plot. The meaning of QQ plot is quantile plot, right? So whatever the sample data we have, for the sample data, it will compute the sample quantiles for the normal, that means Gaussian distribution, symmetric distribution. We have a theoretical quantiles, and it will compare sample quantiles with the theoretical quantiles, right? And accordingly, we can decide whether the data is normal or not, right? Say for simplicity, I am just removing this gender and only for height and weight, and then select QQ plot, right? Now see, in the plot section, we can see the QQ plot also. Look at this, right? Theoretical quantiles along x-axis, and these are the standardized residuals based on the sample quantiles, right? And the data points are the theoretical quantiles along x and along y standardized or sample quantile, right? And this is the reference line. If majority of the data points are very close to the reference line or on the line, the data is normally distributed, right? So this is for the weight data, same is for the height data. Look at this. Okay, and in place, suppose I am selecting this gender wise, so accordingly it gives me a different comparative QQ plot for female, for male, and this is for the height. Okay, same way for female and male, this is for the weight variable. Okay, so we can have a comparative quantile plot, right? And then we can decide whether the data is symmetric, normally distributed or not based on this. Okay, so this is all about the QQ plot. It is used to check the normality of the data, whether your data is normally distributed or not. Okay. Now, many times we need the categorical. Actually, this already I did the numerical by categorical variable, right? Suppose I want to study, let us add some another option that is exploratory, descriptive, and suppose I want to study this weight and systolic blood pressure. So weight and okay. Now another important part is many times we have to add the variables which are adjacent. So you can use shift key and down arrow key or up arrow key for the selection of the variable. Okay. But suppose you have to add non-adjacent variable like in our case weight and systolic blood pressure. So just click on the weight and then scroll down and systolic blood pressure. Hold the control key and press. Now see, both are selected. Okay. And then either you drag it or click on the arrow. Okay. So for adjacent, for non-adjacent, we have a way to select. Okay. And at the same time, I want that according to the physical activity, which is a nominal data, right? So see, we have the output, right? So physical activity, there are only two levels, mostly sitting and moderate physical activity. For weight, for systolic blood pressure, the number of observations in each category, their averages, their medians, their standard deviations, minimum value, maximum value, and as per your requirement, you can select different measures from the statistics section, right? And accordingly, you will get the output. Okay, from the statistics section, you can select as per your requirement. Okay, so all the steps are explained in my presentation along with the screenshot, right? Only the thing is, as I told you yesterday also, online session, it is not possible to conduct hands-on. But if you go through my presentation and if you, I have already shared the data file. So go through the presentation and try yourself. You will get clear idea about the uh, Jamovi, and it is very easy to implement all the techniques, right? So see, this is how we can use, right? So suppose in this section, now this is by default, but suppose I want only say for example 30th percentile and say 60th percentile, right? So accordingly it gives you. So as per your requirement, you can manipulate or you can handle the output in Jamovi. Okay, so this is about the Jamovi output, and accordingly, depending upon the output, you have to write the interpretation, right? Or you have to summarize the output. Okay, at the same time, as I told you, if you go to the plot section, right? So in the plot section, suppose I want a box plot, sorry, histogram, density plot. So I can have a histogram and density plot for weight variable separately, for systolic blood pressure variable separately, for each level of the physical activity, right? For each level of the physical activity. Okay. So this is how we can summarize the data, right? At the same time, we can have a box and whisker plot also, sorry, box and whisker plot, right? And you can add a violin plot. Okay. Now many times what happens? So here this black, a thick black line inside the box, that represents the median of the data. It represents median of the data, right? In this case also and in this case also. In box and whisker, the center point is always median. Okay, but suppose I want to show the mean also on the box and whisker plot. So in SPS, in Jamovi, there is a provision. So just select this mean and you can see this rectangle, right? This square inside the box, it shows the mean of the data. So from here, it is clear that mean and median, they are not at the same location. So the data is not symmetric. Same way here for this data, look at the graph, right? Even look at the whisker, mostly sitting for the weight variable, right? Mean and median coincide. Both the rectangles are of same size. The whiskers are also approximately same size. If you rotate this graph 90 degree, you can see the curve that is also symmetric. And same you can see here also, right? So mostly sitting. So look at this curve, right? And this is mostly sitting. Look at that curve, right? So that gives you idea about the symmetry of the data, right? So this is symmetric for mostly sitting, but for moderate, it is not symmetric. The reason is if you rotate this 90 degree, right? And you can see that there is a longer tail. The curve has a longer tail toward the right hand side. So it is positively skewed. Okay. So this is how we can interpret uh, the analysis, you can interpret the output. Okay, so same way we can compare, and if there is any outlier, so it shows the outlier value, right? At the same time we can have a QQ plot, right? We can have a QQ plot, so we can see the QQ plot here, right? For both the variables you can see the QQ plot. Now look at this. For mostly sitting weight variable, it is histogram, or see the density curve or a violin plot, box and whisker shows symmetry. And here you can see comparative to this moderate, here almost all the points are very close to the line or on the line. But in moderate, the points are at the end, the points are away from the line. And that you can see here, right? Right? That you can see here. Okay. So this is very interesting to analyze the data, right? To understand the data. That is why exploratory data analysis is a tool to understand the data first. And then once you understand the data, once you understand the variable, once you understand the pattern in the variable, then we can go for higher or further statistical analysis. Okay, so this is about the numerical variable by categorical variable. But suppose we have to study two numerical variable or more than two numerical variables, right? In that case, so again, say for example, just remove this, right? So in that case, we have uh, analysis, exploration, and scatter plot. So look at this exploration. So we have a scattered plot. Okay, this scatter plot option. So that is basically you see already I have selected two numeric variables here, but it is a descriptive summary. Okay, either a summary of the numerical variable or numerical by categorical variable. So there is no option about the scatter plot here. Okay, so that is why we have a separate option, and that is exploratory scatter plot. Right now, in this case, suppose I am interested in the data about weight and height, right? So that is weight and height. So just select weight in X, select height in Y. So look at this. Here it shows clearly, right? It shows clearly that X-axis only scale variable is allowed. Okay. Similarly, Y-axis only scale variable is allowed. And if you want to group, you can use a categorical variable. So look at this. This shows the scatter plot. Overall, if you look at the graph, it shows that the pattern is increasing. As weight increases, height increases, or height increases, weight increases, like that, right? So this is just a simple raw data, okay? But it gives you the pattern, right? It gives you the strength of the relationship between the two variables, how weight and height are related to each other, whether there is a positive relation, whether there is a negative relation. So that we will discuss in coming session about correlation and regression analysis. Okay, so this is how we can choose and we can have a two numerical variable plotted using a scatter plot. Okay, another important thing is, so in this case we can use a linear regression line on the plot. So if we apply the linear regression technique, right, so on the scatter plot, according to the data points, by the method of least square, this is the best line of fit for the variable weight and height. That is a linear regression. And after applying the regression technique, we can find out the equation of this line also, and we can use this line for the prediction purpose also. Okay, so this is the simple linear regression, right? And if you want a smooth curve, so we can have a smooth curve also approximately. Okay, that is a smooth curve or uh, linear line. Okay, so we have a linear line. Another, if you want standard error, so it gives you the standard error. That means variation, the margin of error around that. Say for example, if I am checking the linear, so this is the marginal uh, confidence band. Okay, so this is how we can visualize the data. Okay, at the same time, suppose now since I am studying both the variables height and weight simultaneously, at the same time I want to study weight only as well as height only in the same graph, I can choose the marginal densities, right? So look at this. This is along x-axis we have weight. So just on the top of that, we can have a density curve of weight. Okay. At the same time, along y-axis we have height. So to the extreme right, we have a density plot for the height only, right? And inside that, we have a joint occurrence of height and weight, that is scatter plot, right? So this is a density plot. At the same time, if you want a box and whisker plot at the extreme, so you can see the box and whisker plot at the extreme also, right? So this is how we can use all these options, right? And same thing, scatter plot by categorical variable. So up to this, we have discussed only a scatter plot for height and weight, right? That is both the variables are scale. But suppose I want to study the pattern or the relationship between height and weight for male as well as for female separately. Okay, so in the same analysis, we can choose gender and you can drop it in the grouping variable. And you can see a very beautiful chart is prepared, right? So on the same graph, the graph is same. Along x-axis weight, along y-axis height, right? The data points are classified for male, height and weight, right? So all these uh, blue data points are for female, the remaining are for male. And the regression line also, right? For male, this is the regression line. For female, this is the regression line. At the same time, we have box and whisker plot separately. So here also, say for example, if you are comparing weight only, so weight of male and female, right? So you can see in the weight of male, there is a large amount of variation because the whiskers are more elongated than female. Okay, so this is very interesting and important chart for the comparison, right? So this is how we can use all these things, right? So these are the different options. Now, the most important thing, once we have the analysis, this is my analysis. Okay, this is, say for example, this is my analysis, right? And suppose I want R code for this, right? As I told you in the previous session that Jamovi will perform all the calculation in R on the in the backend. So backend in the backend it uses R programming, right? Like in SPSS, we have syntax of SPSS. There are coding in SPSS also, right? But in the background of Jamovi, we have R, right? So just click on these three buttons. Sorry. Mm, Okay. So click on the three buttons and you can use syntax mode. So look at this. For each and every output, we have the Jamovi R command. This is the Jamovi R command, the output, right? This is the Jamovi R command and the output, right? And this is the data source, name of the variables. Okay. See, this is the output. So just one command and you will get the entire output. Okay. So this you can copy and paste in R with Jamovi library and you get the output, right? So look at this. This is for the descriptive summary of weight and systolic blood pressure, right? This is the R code for that. This is the R code for the scatter plot. Okay. So this is possible in Jamovi, right? And if you don't want, just remove that from these options and keep the output as it is, right? Once you get the output, now the problem is how to import the output, right? So here you can see, you can, when you click on the output, okay, when you click on the output, you can copy the image and paste, right? You can export the image, right? Just select the image, export the image, and we have different options available. PDF, PNG, SVG, EPS. You can save that particular output. Okay. So this is one thing. Another important thing which I want to tell you, that is when you are creating the output in Jamovi, right? Like this, say for example. Now here I want some, here I want some output or some, say I want to add something. So following is the descriptive summary, or say for example, exploratory data analysis, right? So you can add your description, right? Say for example, just below this, if you want to add something, right? So you can add the description or you can add your report, right? You can add your report or you can add findings anywhere, right? And again, suppose I want to use this report as a heading. So just click on this heading and just below that. So this is the above table reports that, right? So you can add as per your requirements, reports that, right? And you can add here the entire description, right? So this is how we can use this, right? You can align, you can make it bold and so on, right? And whatever the output you get, so that output will be saved as your entire data as well as the output, right? So this is how we can have the Jamovi, which is a very, very powerful tool or software, data analysis software, right? So now the next is about the question answer. So if you have any questions, so please feel free to ask your questions. Hello. Just a minute. Okay. So can we export the entire page? Actually, we cannot export the entire page as a Word document, but we can save it as a PDF file, or you can copy and paste the tables, right? We can copy the table and paste in Word format.
Can you explain standard error with example? What is standard error?
Okay. So standard error actually when we see when we have a entire population, right? So in the population, when we collect some data, whatever the variable we have, so in that variable, there is a variation. That variation can be measured by the standard deviation, right? But when we take a sample data, right? So when we take a sample data, so that sample is not the only sample, right? So we can have a different sample also. So standard error is defined as the sigma divided by under root of n. It is based on the sample. So what it gives you? It gives you the variation in the sample data.
Got it, sir. Thank you.
Okay. So deviation, mean, quartile deviation, comparison. Okay. Generally, what happens? So when we have a symmetric data, so in case of a symmetric data or normal data, standard deviation is a suitable measure, right? But when the data is not symmetric, so standard deviation is not suitable. So in that case, we can go for the quartile deviation or we can go for the mean deviation. Okay, uh, kurtosis, as I told you, if you see the graph, in case of the kurtosis, what happens? So if we have a peak data means when I have this type of data, so majority of the observations are within the middle range, right? That means the range of the data or the variation in the data is very low, right? But when we have a flat data, so if you look at the extreme values, so in that case, the variation is more in the peak, that is leptocratic, that in case of the leptocratic the variation is less, but in platicratic the variation is more, and the frequency, if you compare the graphs, so you can get idea about the kurtosis, right? All are symmetric, their means are equal, but the variation wise there is a different. Okay, R code. So as I told you, once uh, have performed the analysis, if you want R code also, just simply say for example, so see when we have the output, 1 minute, let me show you. Okay, so suppose this is the R code, right? When I use syntax mode, so this is the R code, right? So you can copy this R code, right? You can copy this R code and you can rerun the analysis in R also. But for that you required this JMV library. Okay, so it is uh, one, that means when you want to repeat this task some number of times, say for example you want to change certain measures or you want to change certain variables, so you can copy this code and just change the variables one by one. Say for example here it is for gender, you can use copy the code, change variable to another, and then at one go you can analyze the data for number of variables. For that purpose we can use this R code. 1 minute. Yes, yes, yes. For the nominal, numerical and nominal. Okay. For the numerical and nominal, that means One variable is numerical, another is nominal. So that always we have to select it using the grouping section. Group by, in the group by we can use that. Okay, normality means what? Your data is symmetric, right? Say for example, if you look at the graph, see this first graph, that is symmetric. Symmetric means we have a normal distribution, which is also known as a Gaussian distribution. So this curve follows the Gaussian distribution pattern, right? So it is exactly a symmetric bell-shaped structure. So that is known as a normal. Okay, and usually in reality, the data may or may not be normal, right? But or it is not exactly normal, but roughly normal, right? So if the data is normal, then we have certain statistical test. If the data is not normal, then we have some other statistical test. So that is why normality is important. So this data is normal, first one, second one is not normal, right? Even this third one is not normal, right? Because the graph is not symmetric, right? Normal means exactly bell-shaped curve, that is known as a normal, normally distributed, or it is also known as a Gaussian distribution. Okay, so that type of chart we can use. That is for the normality. Okay, so if you have any question.
Sir, good evening.
Hello,
Good evening, sir.
good evening.
Comparison of mean and standard deviation. Sir.
Comparison of mean and
Standard.
what is the question here?
Sir, mean value
What is-
and standard deviation value. Which purpose find out the deviation? Standard deviation, quarterly deviation, average
Okay,
deviation.
so basically mean is used to identify the center of the data, where all the observations are centered. So that is the central position of the data. Okay. And
Okay.
standard deviation is used for measuring the variability in the data, how observations deviates from the center. Okay. So that is the major difference between the two. Right? Mean is used for to identify the central position, and variation or standard deviation, that is used to measure the variation or spread in the data. Anything else?
Sir, difference between and deviate mean and standard deviation.
Difference between,
And
you mean mean minus standard deviation? You mean mean minus standard deviation? Hello?
hello, sir. Hello, sir.
Huh.
And the deviation, which purpose find out, sir? Deviation.
Deviation is used to measure the variation. If I collect, see, let us take a simple example. If I collect the data about the marks obtained by the student in particular class, right? So what I want to know? I want to know what is the average. That means the value around which all the observations are concentrated. That single value represents the entire class. Say, I am saying that the performance of my class is 60%. That means on an average, students in my class score 60%, right? When we say variation, so how much is the variation in the data? So in that case, we calculate how the how the scores of students deviates from 60, right? So when we say 60% average score, so there are some students who score less than 60, there are some students who score more than 60, but on average it is 60, right? So I want to I want to find out variation, spread of the data, the minimum score, minimum value and maximum score, right? And when I calculate that using that formula, S square, 1 upon n summation xi minus x bar square. So how each observation, how each score deviates from the mean, that difference, and we by squaring we calculate the variation. So that gives you the variation in the data, right?
Okay.
And suppose if you want to compare one class and another class, one class of student, another class of student, we want to compare their performances. So obviously what we can do, we compare their averages, average of class 1, average of class 2. Suppose their averages are same, right? Then what we can compare, we can compare the variation in the data, right? On the basis of the variation, we can say that the performance of this class is good and for other class is not that much.
Sir, again, standard deviation,
Okay.
quarterly deviation, some comparison, difference.
Okay, standard deviation is used when the data is symmetric. Okay.
Okay.
As I shared the presentation, right? When your data is symmetric, it is exactly bell shape, mean, median, mode. They are identical. Under that situation, we can use standard deviation to measure the variability. But suppose your data is positively skewed, that means mean, median, mode are not identical. So it is positively skewed. It has a longer values, larger tail toward the right hand side. So in that case, standard deviation is not suitable. The reason is the mean is extremely affected, highly affected by the extreme values. Let us take a very simple example. I have the data 1, 2, 3. What is the average of these three observations? 2. What is the median of the three observation? It is again 2. 1, 2, 3. Because the observations are equidistant, right? 1, 2, 3. But when I take 1, 2, another data, 1, 2 and 100. Now when I calculate the average, it is far away from 2. It is towards that higher side because the observations are extreme, right? 100 is extreme value, right? So mean and standard deviation, they are affected by extreme observations when the data is not symmetric, right? So that is why in that situation we can go for quartile deviation or mean deviation. Generally quartile deviation is used for that purposes.
Thank you.
Okay, so thank you very much, madam.
Thank you, sir. Thank you very much. We extend our sincere gratitude to you, sir, for your exceptional expertise and dedication in this topic. Thank you so much. We are profoundly grateful for your dedication and guidance, which have left an indelible mark on our journey toward mastering the art of exploratory data analysis. Thank you so much, sir. We'll
Thank
meet
you.
again tomorrow. Thank you, sir.
Tomorrow's session will be taken by Parag sir.
Okay, sir. Okay.
Okay, thank you.
Thank you, sir. So all of you can leave the meeting. We can meet tomorrow. Thank you.